The hemodynamics of constrictive pericarditis is defined by a rigid, non-compliant pericardium that encases the heart, leading to a fixed total cardiac volume. This pathological state results in two primary hemodynamic hallmarks. One, the dissociation of intrathoracic and intracardiac pressures. Two, exaggerated ventricular interdependence. The rigid pericardial shell insulates the heart from the normal pressure fluctuations of the respiratory cycle. Dissociation of pressures. In a healthy heart, the inspiratory drop in intrathoracic pressure is transmitted to the heart chambers, facilitating venous return. In constrictive pericarditis, the thickened pericardium prevents this transmission. Consequently, the pressure gradient for filling the left atrium, pulmonary capillary wedge pressure minus left atrial pressure, decreases during inspiration, leading to reduced left-sided filling. Enhanced ventricular interdependence. Because the total volume within the pericardium is fixed, the ventricles must compete for space. As the right ventricle fills more during inspiration due to increased systemic venous return, the interventricular septum is pushed towards the left, further reducing left ventricular filling and stroke volume. Cardiac catheterization remains a definitive method for identifying the specific constrictive profile. Square root sign, a rapid early diastolic dip followed by a flat plateau. Mechanism, fast early filling that halts abruptly when the rigid pericardium is reached. Equalization of pressures. Diastolic pressures in all four chambers equalize within 5 mm of mercury. The rigid shell dictates a common filling pressure for the entire heart during diastole. Prominent Y descent, a sharp, deep drop in atrial and venous pressure at the start of diastole. It reflects a rapid, unimpeded early filling of the ventricles before the pericardial limit is hit. Kussmaul sign, a paradoxical rise or lack of fall in jugular venous pressure during inspiration. The RV cannot accommodate the inspiratory increase in venous return due to the non-compliant shell. The most critical diagnostic finding in cath lab is ventricular discordance, which helps distinguish constrictive pericarditis from restrictive cardiomyopathy. During inspiration, right ventricular systolic pressure increases while the left ventricular systolic pressure decreases. They move in opposite directions, that is ventricular discordance. In restrictive cardiomyopathy, right ventricular and left ventricular systolic pressures typically rise and fall together. They are concordant because they are both subjected to the same intrathoracic pressure changes, that is ventricular concordance in restrictive cardiomyopathy. Modern imaging translates these hemodynamics into visual markers. On echocardiography, features include the septal bounce, an early abrupt shift of the septum towards the LV in early diastole, and annulus reversus, where the medial mitral annular velocity E' is higher than the lateral velocity, reversing the normal pattern. That is because lateral annulus is tethered by the thickened pericardium. Cardiac MRI or CT, useful for visualizing pericardial thickening more than 3 mm or calcification, and assessing respirophasic septal shift via real-time cine sequences.